but that's okay. All right, so let's see if anyone's brave enough. Who thinks they've got a viable general term? It's working for you. What do you have, Catherine?
I've got the series from n equals 0 to infinity.
So she's going greater than or equal to 1. 0.
Yeah. Then x to the 2n plus 1.
Okay.
Over n plus 1 factorial.
2n plus 1 factorial?
No, n.
Check it. Okay, I'm going to check her. Yep. Yes. So we're going to fix hers. It's got 2 issues. So if yours isn't this, yours it still could be right. That's okay, Catherine. You were brave. But I'm glad it was. I was hoping it would be wrong because it's our first one. And I want to see how we should be able to catch it. When I put in a 0, I need to generate that term. She's good with the x. She's good with the 1 factorial. She's good for the first term. When I put in a 1, I need to generate x to the third. She's got that. She'll have over 2 factorial. And it would be positive. So I need to tweak this 2 ways. Give me a tweak on it, Luz. Okay, 2n plus 1 factorial will fix that. So now I'm getting x to the third over 3 factorial. When n is a 2, I'll get x to the fifth over 5 factorial. That's good. What else do I need on it? I need an alternator. -1 to a power, but you got to be careful with that power. What do you think, n or n plus 1? Just n. Okay, now, you could have had it different. Did anyone else have a different one? No, you're starting in. I like this one. This one's my favorite. But you could have done 2n minus 1 over 2n minus 1 factorial. Then your n would have started at what? 1, and this would have needed to be tweaked to a n plus 1. Did anyone do that? Is that what you did, Katie? It's totally right. 100% correct. All right? And a lot of times we'll have, like Thomas said, that series in here, so you don't have to, you either have to put the n greater than or equal to 0 below your general term, or put the series symbol in there. Good. Next. And this is what it's when it says you might have to adjust it to make it look prettier. The person who chose 2n minus 1 and has the n plus 1 is right. But maybe you want to tweak it so that it's more controlled by like a lower degree of n. So why are series nice? First of all, you can substitute stuff into them as long as we don't change the center. So I can do sine of 5x, and it'll be just fine. Yes?
When you do the series, is that a plus or an equal? Are you putting it in the...
That was my finger. It was. It was my finger. Come on. A disturbance in the force. No, it was my finger. I did not fart in front of the whole class that loud, but I would keep it down. All right. You saw me run my finger up there. Thank you. Yeah. I know I don't even know your question. I'm so embarrassed for not farting.
Would that be a plus or
Plus, or equals. I'll take either. Oh. Yeah, I actually am just fine with this being left off as long as you put your count down there. But you have to tell people where they're starting. All right, you can multiply or divide by anything too. So if you can do cosine x as series, you can divide by x to get, if you want to get cosine x over, as long as we don't change the what? Yes, we can integrate, we can do derivatives. They're nice. This is for our next lesson. So let's move on to number 7. McLaurin, thank you. What would I say? Thank you. I am recording under there. So why do I say thank you, McLaurin? Because I know the center and I can just modify what I've hopefully already memorized. So what I'm going to do is, you might say, we did this already. We did for the polynomials. We never had this general term and we didn't understand quite why we were generating them. So we're going to say sine of x first. X minus x cubed over 3 factorial x to the 5th, 5 factorial x to the 7th, 7 factorial, first 4 non-zero terms, plus, general term, we just did it, -1 to the nth, 2n plus 1, x to the 2n plus 1, sorry, x to the 2n plus 1, and then on the bottom, 2n plus 1 factorial and tell the person that you're starting at 0 or put a series symbol in it. All right. Now, what do you think I'm allowed to do for x squared? Just put x squareds in for all of these. So I'll do x squared minus x squared cubed, right? So minus x to the reason I'm writing it out is these are always multiple choice. We're going to do 2 examples in just a second. I'm going to make sure, see how you guys do. Then I'd have x squared to the 5th or x to the 10th over 5 factorial minus x to the 14th over 7 factorial plus ... Watch. The general term, negative 1 to the n, it'll be x squared to the 2n plus 1. Your general term can just be modified as well. So x squared to the 2n plus 1 over 2n plus 1 factorial. If it's multiple choice, what do you think might be in the general term? X to the what? 4n plus 2. Check it. And it should work out. So go ahead and take a look down here. I want you to try x cosine x with a good general term. Then we're going to try 2 multiple choice. Or do you think you have this down? I kind of think we do because we practice. I think we're okay with that. I want to go to 2 multiple choice from AP. They're both number 17s because they're different tests. So it says, which one of these is the Maclaurin for e to the 3x? They want you to make one. That's easier than you trying to figure out what was made. So this is a very easy question. If you know how to generate e to the x, and we don't switch the center, so there's 2 ways this is tested. The easy way, which is this one. I have no idea which one it is. I know there's no alternator in E, so I'm going to eliminate that one. So the work you should be doing, like, what is everybody writing down? They're writing out e to the x. They have it memorized, hopefully, right? And then for all the x's in the expansion, what are you putting in? 3x. I go that fast, blah, blah, blah. I'm just checking as I go because so far I need one more term, right? So I need to do 3x quantity squared over 2 factorial. I'm getting e. E. Okay? Tempting to put d if you don't parenthesize the 3x. Careful with that. It's obviously not the other ones. What's letter A? E. Right? This is our answer with an alternator, but it should be E. Now, lastly, before I let you just chill for a bit, because we've been talking a lot today, this is harder. Which one is this? So you don't generate it. You have to decide which one it is. Eliminate ones you know it's not, and then try the others. That's only it. So ask yourself, is this cosine's expansion, and what should yourself say? No. Got an issue with the factorial. Is this sine's expansion? No, so close. An issue with the... This is harder. Your brain has to work backwards. So we know it's not this one, because that would have evens. We know it's not that one, because that would have x cubed. I'm not sure of the other ones. I haven't done it since last year. What do you think I do with letter C? What do you think I do? Try it. Take signs. I'm not sure if it's C. Like I said, you're my only hour of this year. Here's signs, right? if I divide those by x, I get 1, x squared, there it is, right? That one's working. What if that one didn't work? Unfortunately, I have to go try the next one. It's kind of like a work forward, backward. All right, so nothing due tomorrow. But 4a, I want to see how long it is. I haven't looked at it before. I want to see how long it is.
20 pages. Give us at least 2.
Let's see if it's. Now, 4a is doable. It's just 1 through 13. This whole packet isn't 4a, it's just this. So 4a due Monday. If you want to start number 1 and see if you can write that out and give it a try while you're here. You're doing e to the 2x centered at 3. Does that make you go thank you or you're super mean? You're mean, thanks. Right? Because you can't just modify it. You have to e to the 5x. You know. Hello, distance learners. We're done. Thank you for sticking with us. E diddy, does it make sense?
Yeah, the only thing that sucks is
Nothing does.
the last part. I don't know how to build them because I wasn't able to do it at the beginning of the semester.
Oh.
When they did series,
Build which ones?
like